first few questions. Question number 4. I saw a little more, several students missed that. The answer is A, database definitions, but several students select D, DBMS subsystems. So actually, in this class, we didn't talk about subsystems much. Some internal, in order to make the whole system work, some specific subsystems, working for different functionalities. But here, this part, remember the procedures. It belongs to the database schema, and we write the SQL commands. So here, we talk about, this belongs to the database definition. We talk about that because first, we use SQL commands to write it, or SQL statements to write it. All right? And the second, when we export our database schema, because sometimes if we want to move our database from one database server to another database server, so we want to export the database. We can export schema and the data, or you can separate if you like. When we export the schema, everything contained inside the schema, including stored procedures. So that's the reason we treat as the database definition part. The metadata, okay? The metadata contains that. So that's, some basic understanding. All right, a few students missed this one. Others, not too bad. Number 6, I remember I mentioned that. A few students select C. C, I took 2 points off. The reason is B option is more important than C option. B option tells us you make sure your data is correct, no problem. So that's the first priority. We want to make sure there is no consistency problem in our data. Then second, we want to speed up. We want to make the, response time as fast as possible. So C is second best. B is the best answer. Data consistency, always the most important. We talk about this in the notes. A few students miss that. And other than that, 7102 missed that. Most of you can get that. So here the reason is, for those 2 students who missed this one, the reason is the denominator is not a power of 2. Because the binary, here, when we convert to the binary, for the fractional part, in order to get exact representation, here, if it's not power of 2, then you cannot get exact. You can only get approximate. You have to truncate a few bits, certain number of bits. So here, if you really look at the denominator, this one, not power of 2. All the other 3, you can see power of 2. So that's the, 2 students missed this one. All right, other than that, compile, so all other, number 12, several students, quite, probably 4 or 5 students miss number 12. Answer is no. Actually, it's not very useful. Yeah. Actually, almost no business companies use this type of, this is a, proposed as the academic projects, but, business world cannot use this new idea. Yeah. But, the reason some students select this one, so later we talk about a modified version, not exact this version, a modified version. So ORM, right? Yeah. So the ORM is pretty popular in business world. Yeah. So what's that ORM? Object relation mapping. Okay? Object relation mapping. This is popular one. But that's different. So here, first object. Yeah. So you see the object. Yeah. So this object is not arbitrary object. So this object mainly entity object. Okay. Yeah. Mainly entity. Yeah. Yeah. If you want to use the relationship, that's okay. Yeah. Yeah. So this. Or if I do not use entity, because entity, that's very confusing. Most of the time, it's entity. Yeah. So this object here typically corresponds to a Java bean. A Java bean object. Okay? Yeah. Yeah. Contains data, contains structured data. Yeah. And do the mapping, when we do the mapping, it's not a binary to table mapping. Yeah, because even Java bean, we map from Java class to table definition. Yeah, so the mapping is between these two things. Yeah. A Java class definition of the Java bean. Okay, a Java class. A SQL table. Table definition, SQL table definition. Okay, yeah. Both format text. Java class definition is text. SQL table definition also text. Okay, so no binary involved. Yeah. That's the ORM mapping. That's the popular way used in the business world. Yeah, but not the original idea. So this original idea, between the binary objects. So that's not, business people do not like that. Yeah. All right. Yeah. So 4 or 5 students miss this question. Yeah. Yeah. Because there is some background like this. I talk about in class. Yeah. So you can still find. In our notes. Yeah. Then, other than that, exists. Yeah. All right. Yeah. Yeah. Okay. Yeah. Number 15 also okay. Yeah. Number 16. Yeah. A few students pick 1 to M. Yeah. Yeah. But yeah, probably. Yeah, because when they look at the problem entity problem. The content of the problem, a math problem. In a math problem, you just think about, is it possible we allocate it to different categories? Yeah. Because in one problem, we may use, knowledge from different categories. Trigonometry, geometry, inequality, right? Yeah. So, the knowledge in those different categories we all practice in one particular problem. So we, to make a our users, because to give our user students practice chances, so we like to allocate it to different categories. Yeah. So 1 to m and m to 1. Yeah. M to 1. Yeah. So that's, oh, yeah, sorry. Yeah, those of you students, they may pick m to 1. Yeah. M to 1, yeah. Because multiple problems map it to one category. But we also allow 1 to m, right? One problem map it to multiple categories. So that's the m to m. So two directions. So 1 to m, m to 1, together, m to n. Yeah. That's what we mean. Okay? Yeah. So, I talk about this in class. I use this as an example. Yeah. All right. Yeah. So that's, not too many. About 2 students miss that. Yeah. Other than that, oh yeah, another one. Right. Number 17. Yeah, that's the, quite some students miss this one. Yeah, but here, I like to explain a little more. So here, my language probably a little confusing, but still, so here I took 2 points from several students, quite some, 30%, 1/3 of you, select A, so I took 2 points, not 4 points, because I should make the wording better to avoid the confusion. Here, let me explain. But here, actually, if you are familiar with the background, you should choose B, because look at the first version. That's the SQL 1, okay? SQL 1, SQL 2. SQL 1 version. SQL 1 version, the structure, it's all tables are mixed, same place. All tables from all business applications are putting together. Remember, each table we use one physical file to store it. So all the tables for all business applications, just because they are stored as individual files. So they are not separate. Those tables are not separated for different business applications. So mixed. That's the SQL 1. Okay? SQL 1. So at that time, even there is no schema concept, right? Because everything stored in the same place. Okay? Hard drive, same location. There is no separation, no table separation corresponding to different business applications. Okay? Yeah. So then SQL 2 improved that, because when people use, they do not feel convenient for different business applications, how to identify those tables. So it's hard. You need to, do bookkeeping, right? Table 1 belongs to business application 1. Do bookkeeping carefully. So that's not convenient. So SQL 2 improved that. So then they create a schema concept, database concept to separate. So organize them under different database schema. In that way, more convenient. So you can, you do not need to do bookkeeping, right? So you just go to individual databases, and then you can access all the tables. So that background. So in the Rachel respect, Rachel, then SQL 1, because at that time even no schema concept. So Rachel, so then people just say the schema contains all tables. So if you really want to call a schema, containing all tables. So that's the situation. The history a little bit. So that's something. All right. Because you can see if one database schema contains all tables, so If you use that concept or not, no difference, right? Yeah, all tables are stored same location, same place, you know. So you call it schema or not, so it's not important. Yeah, but for SQL 2, it's important. Yeah, different schemas, because you can directly look at the tables for different business applications. Yeah, yeah, things like that. Yeah, yeah. So that's some background. Yeah, yeah. That's Mr. 19. Missed a little bit. Yeah, but it's false. Yeah, a small number, 2 or 3 students missed that. Yeah, because the string with quotes we treat as normal value. Yeah, it's normal value. The null value without quotes, it's not normal value. Yeah, it's a special value. Yeah. All right. Yeah. So do not equalize these 2 different cases. Yeah. All right. Yeah. Number 21. Yeah, quite some students missed. Yeah. So as I know, at least 4 or 5 students missed. Yeah, because if you know the meaning, here I check your understanding of the meaning. If you know the meaning, you can see m must be greater or equal to n. The reason is n means the number of total digits, right? Yeah, so here you have a decimal point. Yeah. There are a certain number of digits before the decimal and a certain number of digits after the decimal point, right? Yeah. After that part is n. And all the digits, that's m. Yeah. But if before digits you only have 0, yeah, because 0 you can ignore it, right? If 0, so you do not count it, then m equals m. Yeah. Yeah. But other than that, you know, m should be greater or equal to n. Yeah. Yeah. Yeah, but you know, some students selected yes. Yeah. 4 or 5 students at least. Yeah. Number 20 also several students. Yeah, not too many. 3 or 4 I estimate. Yeah. Here we use the alphabetic order. We use the dictionary order. Yeah. A few students give me, you know, 2 students probably give me that one. So they just look at it as the numerical value. But here, when we use the quotes, so in SQL, yeah, so probably later I need to talk about data in quotes. Yeah, because sometimes we use quotes around our data, our numbers. Sometimes we do not. Yeah. For string values, we have to use quotes. Yeah. Otherwise, you get syntax error. Okay, the string value you have to use the quotes. Yeah. Single quotes, double quotes. Single quotes, that's the SQL standard. Double quotes, supported. Not a standard, but supported. Yeah. So you can use it. Yeah. Legal. Yeah. Yeah. But we do not treat it as SQL standard. Yeah. Numerical values. Yeah. So here, numerical values. Numeric values. Both ways, okay. Quotes way, non-quotes way, okay. Both ways works. Yeah. Yeah. Because numerical value in your table definition, you specify your field takes numerical value, okay. But when you enter data, you use quotes or non-quotes, both legal, both ways legal. Yeah. But if we have freedom to choose, we like to choose non-quote way for the numerical, if we have freedom to choose. Okay? So usually, by default, we choose the non-quote way to enter numerical values. Yeah. All right. Yeah, but here we have the quotes, so we treat as string values. So when you see these quotes, so we treat, yeah, because here I said string values, right? So no confusion. So do not use the numerical values here. The string value comparison, you use the alphabetic order or dictionary order. Yeah. So alphabetic order. Yeah. Yeah. In that way, so you have to take a D. Yeah. You compare first character. Which one is larger? Yeah. All right. Yeah. So 3. Yeah. About 3 students have missed this question. Yeah. Other than that, I feel right should be yeah. So the last 3 questions, I think no problem. Yeah. Yeah. So that's the common. Yeah. These questions, yeah, based on my impression, the common mistakes. Yeah. All right. I will post this file, okay, so you can, see my comments, yeah, explanations. You can study, okay. All right. So for the midterm, yeah. All right. Yeah. All right. So let me stop here and go to part B. So we have about one half the content. Yeah. So today, it looks like today we cannot go to part C. Today, the remaining of the class, let us just complete part B of module 4. Yeah. All right, here, part B. Yeah. All right. So we, table join, yeah, set operation last time. Okay, yeah. So then we did a set union example. All right. Then new topic, string pattern matching. Yeah. So first, let's look at this topic, string pattern matching. There are 2 commonly used methods for string pattern matching. Yeah. So today I give you a short introduction. Yeah. Later, I will spend more time to talk about the second way. Yeah. So I probably use more than one half of the class. Yeah. Probably less than one class, but more than one half of the class to talk about that important string matching method, regular expressions. Yeah. Today I just show you simple examples for these 2 methods. Yeah. All right. Okay, all right. Yeah, because later I will assign you several such questions. Yeah. Some of the questions not very easy. Yeah. All right. String pattern matching. The first one is an easy way. Yeah. The first way, using partial string matching. Yeah. All right. Comparison operator, like operator, like. Okay. Yeah. So we match part of the string. Yeah. We describe the pattern for part of the string. Yeah. And we use this like operator to match it in a simple way. Yeah. Usually for question using this way, relatively simple. Yeah. Straightforward, simple. Yeah. All right. Special characters for pattern description. We need to use a small number of special characters, yeah, to describe the pattern. Yeah. So what's that? One is % replaces an arbitrary number of 0 or more characters. Yeah. In Unix we use star, yeah, but here to work with this like operator, then we use this %, not a star. Okay, yeah, this special percent sign, yeah, to represent 0 or more. Okay, yeah. So this place, you can imagine, matching the string part of the string containing 0, nothing, okay, or more characters. Yeah. And the underscore, another special character. Here it's the underscore. Yeah. In Unix we use question mark, right? Single character. Yeah. But here this is SQL. Yeah. SQL we use underscore character replaces a single character. Yeah. Sometimes we want to match a single character. So underscore here. Yeah. So this is the SQL way. Okay. All right. Be aware of the performance issue. Yes. Yeah. Right. Yeah. So usually for the relatively simple case, so we don't worry about the performance issue. Yeah. If it's too complicated, probably there is a performance issue. Yeah. Especially for large data amount. Yeah. Because when we do pattern matching like this, we search. We try to search our data, to get selected data, right? Selected rows. Yeah. Those rows should match the given pattern. Yeah. But think about if your data amount is too large, and when you do the search like this, it could be very slow. Okay? So you need to be aware of this problem. Okay? Yeah. So this kind of search, when you use, you need to consider this performance issue. Yeah. Definitely, you cannot use this way to do the, search engine functionality, right? Yeah. Search engine cannot use this kind of search. Yeah. Because that would be too slow. Okay? Yeah. Too slow. Yeah. So you need to be aware of the, performance. Yeah. Try to use it in a correct way. Yeah. Otherwise, very, very slow. Yeah. All right. Specify escape character. Then sometimes you may need to escape some special characters, right? Yeah. For example, this percent sign, it is a special character. Yeah. Think about, sometimes you may want to use this percent sign literally, right? Yeah. You don't want to treat that percent sign as a special character. You want to use it as the literal character. Okay? Another case, you may like to use the underscore as the literal character, right? Yeah. So in that case, you may like to escape it. Escape. Yeah. But in SQL, when you need to use the escape character, you need to specify it. It's different from, other programming language. Usually we use backslash as the escape character, right? Yeah. So most of the time in other programming languages, we use backslash. Yeah. But in SQL, you cannot assume by default the backslash is the escape. You have to define it. Yeah. You have to declare it. Okay? You specify it. Yeah. And escape character is specified after the string use the keyword escape keyword. So you declare it. Then that character can be used as the escape character. Okay? Yeah. So even for the backslash, you need to declare it. Yeah. You cannot assume backslash is the default escape character. Okay? So for example, so we declare it. Yeah. So here, first, we declare, after the escape keyword, we declare that backslash as the escape character. Then we use it in our pattern description. Pattern. Yeah. AB escape, that underscore. So we use underscore as the literal character. Then we also escape percent sign. Literally, we use it literal percent sign. Yeah. By escaping it. Yeah. So that's the simple example. Yeah. So definitely you can use other character for the escape, right? Yeah. So not necessary this backslash. Yeah. Yeah. All right. So that's the SQL rules. Yeah. Yeah. All right. So the like. Yeah. All right. The like, yeah. Later, yeah. Here I just give you the rules. I do not give you many examples. Yeah. So later when we have chance, we can practice a few more examples. Yeah. Yeah. But usually, this operator is very easy to use. Yeah. So we can learn how to use it easily. Yeah. But the second way, much harder. Yeah. The second way, use regular expressions for patterns. Yeah. Yeah, actually, in several programming languages, they all support regular expressions. Yeah. You know, JavaScript, you know, PHP, Java, you know, C++. So, you know, most of the modern programming languages, they all support regular expressions. Python, yeah. SQL also support regular expressions, yeah, because this is a powerful way to describe many complicated, sophisticated string patterns. Yeah. Yeah. So there are many rules, and in this class we just look at a few small number of most commonly used rules. Yeah. Yeah. But not today. Yeah, next time, not today. Next time, the rules we will learn, we only use one slide to cover those rules. Yeah. So not too many. Yeah. Those rules covered by just one slide. Yeah. Yeah. So we will go through next time. Yeah. All right. Here I just give you a simple example. Yeah. Regular expression for patterns. Yeah. All right. Look at this question. Yeah. Look, list the name and address for those employees whose addresses satisfy the condition. The street number has exact 4 digits. Here you can see we need to describe in a specific pattern for a string. Yeah. The street number, we know, in the address, the first few characters, so usually are used as the street numbers. So we want to describe how to describe exact 4 digits. Yeah. Yeah. Here, in this situation, we need to use the regular expression. We need to use the power of the regular expressions to describe it. Yeah. All right. So let me show you the example. Yeah. All right, so the first part, easy. We only need to look at the string matching part. Yeah. Address. First, the operator regexp, R-E-G-E-X-P, regular expression, 6 character. This is the operator name. Yeah. Yeah. After that, then inside the quotes, single quotes, we use the regular expression syntax to describe the pattern. Yeah. Here, let me explain one by one. Yeah. First, the street number must, because usually the position of the street number at the beginning of the address, right? So when you start address, you get a street number first, beginning. Yeah. So look at this sign. this hat or wedge, this symbol, it means the beginning of the string. Okay? So this symbol in regular expression, it means the beginning of the string. So matching the beginning of the string. Okay? All right. After that, you see a pair of brackets. The pair of brackets describe a list of options in it. A list of options in this bracket. So the next part of the pattern. Here, 0-9, that describes a digit. Because this digit selected from 0 through 9. 0, 1, 2, 3, 4, through 9. The 10 digits. So 0-9. The range. So here it gives you the range. But this bracket only tells you want to use one character in this range. So this bracket, just the one character in the range. Okay? One of the digits. Here you describe just the one character. Okay? All right. Then, after this bracket, a pair of curly braces. It tells how many times you want to repeat the previous pattern. The previous. All right. So that one digit character. Here 4, it tells us repeat 4 times. The previous pattern should be repeated 4 times, 4 digits. The previous pattern is one of the digits. But you repeat one of the digits 4 times. Just repeat the pattern 4 times. It's not the same digit repeat 4 times. Okay? So each time you can use different digits. The pattern is repeated 4 times. Okay? But how do you describe? Because there is exact part. Okay? So it must be 4 digits. But if a string number has 5 digits, then you should exclude it. Exclude the addresses with 5 digits. So how do you exclude? Because when you have 5 digits, first 4 digits, that part matching this pattern, right? Matches this pattern. Then we have to tell the sequel if the 5th character is the digit. No. We do not want to take it. If the string whose 5th character is also a digit, then we do not include it. So here you can see there is a space character right after the first 4 digits. Space. So immediately after the first 4 digits, you need to map it a space character. Terminate. So this space character is treated as the terminator. Okay? Termination indicator. Okay? Termination indicator. So you terminate that 4-digit pattern with this space character. Because in the address string, if an address matches this exact 4-digit string number, after the 4-digit string number immediately follows a character, a space character. So be careful, this little place. If you address all these parts, then after that, here, because after the space character, nothing. nothing after it. Nothing after it, that means everything. Everything after appears after the space character, okay. Yeah. Yeah. Because you don't have any restriction on it. Okay? No restriction on the remaining part. So that means everything should be fine. Yeah. All right. So that's our first regular expression example. So think about, the style here, the logic, the rules. How do we apply the rules of the regular expressions? Yeah. Try to get used to it. Yeah. All right. Yeah. So that's our. And in this part, I only give you one example. Yeah. Because in later, somewhere, I will show you more examples. So after I give you the many rules, yeah, in one slide, one PowerPoint slide, yeah, only I give you a table containing those commonly used rules. Then we can practice more examples. Yeah. All right. Yeah. B.5, insert statement. Yeah. So let's look at our first insert statement, first round. Yeah. Because in our part C, I will show you some more cases about insert statements. Yeah. All right. Yeah. So insert statement, in its simplest form, insert is used to add a single tuple row to a relation table. Yeah. Yeah. The simplest form. All right. So the first version, the simplest form. Okay. Yeah. So one insert statement, we only insert one row of data into the table. Yeah. Yeah. All right. So we must specify the relation name and a list of values for the tuple. Yeah. The values, yeah. So remember the values, we need to go back to what we learned before. Null value, for example, default value, right? Yeah. Primary key, auto increment primary key. So those cases, yeah. So we have a few cases we need to consider when we insert a new row. Yeah. All right. The values should be listed in the same order in which the corresponding attributes were specified in the create table command. Here, yeah. Same order. Yeah. So when we define our table, we list the attributes in certain order, right? Yeah. But when you insert the data, there are several versions. Some of the versions, you do not need to repeat the list of attributes. Yeah. You do not need to repeat. Yeah. So you just follow the same order. Then the DBMS just use the same order of the attributes to do the insertion. But sometimes, another version, you can list those attributes. You explicitly list some of the attributes. In that way, you can change the order because you list those attribute names explicitly. Yeah, so we will see those versions. Yeah. All right. Yeah. Look at the first version. Yeah, this example. Insert into employee table. After employee table, here we only give the table name. After employee table, we do not provide attribute names, a list of attribute names. We skip it. Yeah. If you skip it, the attribute names, then the DBMS just used the original attribute list in employee table definition. Yeah. So yeah, that you can save a lot of typing. Yeah. So this is the first version. Yeah. Commonly used, also commonly used version. Okay, all right. So here you only need to provide the values following the given order of the attributes. Yeah. You know, first name, middle initial, last name, you know, and so on. Okay? Yeah. Yeah. So you have to use the exact same order. Yeah. So be careful. Yeah. All right. Here, yeah. When you look at the data, so here, one row of data. So when you look at the data, for some table fields, we do not use quotes. Okay? All right. So here, look at these two numbers, we do not use quotes. Yeah. Okay? The first one is the salary. Okay? The salary number. Yeah. Then the last one, 4, department number. Yeah. So these two numerical values. Yeah. Numerical or integer values. Yeah. So here, yeah. So we do not use. Yeah. Yeah. In order to separate, yeah. In order to improve the readability of this insert statement. Yeah. So it's better for numerical values, we do not use quotes. Okay? Because in that way we can see what are those fields? They take numerical values. Yeah. All right. But I also said before, even for numerical values, if we put quotes around numerical values, it's legal. Okay. Yeah. So you can insert into the table successfully. It's legal. We do not say illegal. Okay. Yeah. Just we say the readability not as good. The readability is, slightly worse. Yeah. Because you cannot tell which field is a numeric field, which field is a, string field. Yeah. It's hard to separate. Yeah. Yeah. All right. But the quote way for numeric values, sometimes we need that. Yeah. Sometimes we may need to use that, the quotes way. Yeah. So that's why SQL support both ways. For the numerical values, the quotes representation and the non-quote representation. Yeah. So that's, one special property for the numerical values. Yeah. For string value, only one way, the quote way. Yeah. All right. Second form of insert. Yeah. We have 5 minutes, so let us finish this page. Second form of insert. Allow the user to specify explicit attribute names. Yeah? Because sometimes we do not need to provide values for all the attributes, right? So the many attribute values, we have different ways to provide their values. Yeah. Null value, sometimes we can use null value, sometimes we can use the default value. Sometimes we can use the auto increment value. Yeah. Those three cases, typically those three cases, we can provide, values in an implicit way, not explicit way. Okay. All right. So here, that corresponds to the value provided in the insert statement, the second version. Yeah. The values must include all attributes with not null specification and no default values. Yeah. Must. Yeah. actually the auto increment. Yeah. Auto increment, we do not need to provide the values. Yeah. So there is a, for MySQL, auto increment case. Yeah. But it's not a general case. Yeah. Auto increment, it's not a general SQL case. So it's a MySQL special case. Yeah. All right. So, yeah. If attributes, if you declare not null and you do not provide default value, then you have to provide explicit values. Yeah. All right. Attributes with null allowed or default values are the ones that can be left out. Yeah. Because if you skip those attributes, the DBMS knows what value to use. Yeah. First, look at if there is a default value, default clause. If there is a default value, just use the default value first. If no default value, then look at if there is not null restriction or not, constraint or not. If there is no not null, the DBMS just use the null value. Okay? Yeah. All right. Look at the second version of the insert statement. Insert into employee, parenthesis. Here, we only specify 4 attributes in this order. Here, we do not have to follow the original order. Yeah? You just use the order you feel convenient for you. Okay? Yeah. So here, F name, L name, department number, and SSN. Yeah. So the data, the same order. Okay? Yeah. Yeah. All right. Yeah. So these 2 versions. Yeah. For one row statement, one row insert statement. All right. Yeah. So let's yeah. So we finished part B. Yeah. In part C, we will learn a few more versions of insert statements. Yeah. Especially, we want to learn the multiple row insert statements and the batch insertion. Another important version is the batch insertion. Okay. So yeah. So I will talk about, those. In not many cases, just a few more cases. Yeah. So that update. So then, yeah, in part C, we will do that. All right. So that's it.